Welcome, geometry class, to lesson number 7, distances and parabolas. I hope you have your lesson notes printed out or some binder paper ready to go. For this problem, if you have binder paper, you're going to need to draw this. And I think if you were to sketch this yourself, maybe you would even be able to do more with the notice and wonder, because you'll have looked at this carefully to figure out what's going on. Because the first thing we're supposed to do is to say, what do we notice and what do we wonder in this picture? Well, I'm going to just pick one point. So I picked this point right here, this A. And I'm looking at this and I'm trying to notice and wonder, what do I see? Well, I see a blue line down here, this line. And I see this point F, and I have dashed lines going from A to F and from A to this line. So when I say the line right here, we need to give it a name. I don't want to keep saying the line. It has a name, and that name is directrix. And so it's going, if I think about it, I'm going directly from A straight down to this line. So this is directrix. And so we're going to look at this distance from A to the directrix and from A to this point F. And I'm looking at that distance, and there I highlighted in blue, and I'm going to go down to the directrix, and I'm looking at that. And now that I've highlighted them, you might, if you had it printed out, you could take a piece of paper and measure, just by measuring on it from 2 dots on a piece of paper, and you would notice that, oh, those are the same length, that they are equal measure. And that's one thing I noticed, and I'm wondering about these other points. And so now I'm going to pick a different point. So now I picked point B over here. I picked a random point, this one. And I'm going to look at that same thing, the distance from B to the point F, and the distance from B to this directrix. And I've got that distance to point F and the distance to the directrix. And sure enough, those are the same length. They're not the same as they were here to point A, but these two distances to point B are exactly the same. Well, let's pick one more just to double check. And so I picked way down here this point C. And I'm going to check the distance from C to F and C to the directrix. And sure enough, those are also equal distance. So this is something that I noticed about it, that from any one of these points, if I check the distance from the point to this point F and the distance from that point to the directrix, they're always the same length. And that's an interesting thing to notice. So now I wonder, and now that I notice that these have the same distances, what do I wonder? I'm wondering about what's so special about all these points. What makes these points where this distance is always going to end up being the same? So I wonder what would happen if we were to connect these points. So I take this point A and I connect it through all these other points to C, and I come all these other ones, and then B. What are we going to get? Well, when we do that, we get this shape. And this shape is called a parabola. And in fact, what we just discovered, or what we just did through our noticing and wondering, is the definition of a parabola. And the definition of, and I'm sorry, we need to give this point F a name, just instead of just saying point F all the time. The name of that point is focus. So please write that down as well. So we've got this line that we call the directrix, and we have this point called the focus. And all of the points on this parabola are equidistant to the focus and the directrix, which is our definition. A parabola is a set of infinitely many points, each equidistant to a point, the focus, and a line, the directrix. Remember to pause the video so you can write these things down. So now let's look at some pictures. I've got some pictures of parabolas. I've got 6 different parabolas here. We have some that have what I look and say, oh, they look like they're smiling. These are upward. They open upward parabola, and all of these one open, and this one opens, and so does this one. And we have 2 parabolas that open downward, so they're facing down. Okay? And in these pictures, we're looking at the fact that there's a point F, that's that focus. We have this blue line, which is our directrix, and we also have another point on the parabola, this point right here. So these are just some things that I'm noticing about it. And we notice that the distance from the directrix to that point on the parabola and the distance from that point on the parabola to the focus are equal, because any point on the parabola is equidistant to both the focus and the directrix. So those two measures are the same, and they are on a line, a straight line. They're perpendicular. What we could say is they are perpendicular to the directrix. And in this second graph, same thing. We have this line from the directrix to the focus, and this point on the parabola is halfway between the two of them. And we see that in all 6 of these parabolas, they have that same thing going on. Well, if we looked at instead of the entire distance, we can see that it's made up of these 2 pieces that were there, but this entire distance from directrix to focus, and we looked at this distance that goes straight across through the focus. This has a length of 2. This line had a length of 1, and this had a length of 2. Let's look at the next parabola about its distances. Well, the distance from the directrix to the focus is 3, and if we drew a line that is perpendicular to that goes straight across through the focus, and we notice that its length is 6. The next parabola, well, this distance from directrix to focus is 5, and this distance that goes across from one side of the parabola to the other through the focus is 10. And so there seems to be a correlation between these. So I want you to pause the video for a moment, and in your diagrams I want you to draw the same idea with these 3 here. And think about the length from the directrix to the focus and the length across the parabola through the focus. So pause the video, answer these 3, and let's check them. Okay, so we have here the length was 2 from directrix to focus, and the length across the parabola was 4. The next one, the length we have is 5, and across the parabola is 10. And on this one here, the length from directrix to focus is 2, and across is 4. This yellow line that I'm drawing that goes straight through the focus, it's parallel to the directrix, perpendicular to this line. This yellow line in each one of these, that's got a special name. It's called the latus rectum. And so it's the distance across the parabola through the focus, and it is perpendicular to this line here. So here we've got our statement that I want you to write. The greater the distance between the focus and the directrix, the wider the parabola is. So you'll notice that we have a narrow parabola and a wider parabola. As this length from directrix to focus got larger, the parabolas got wider. But not only that, they also got narrower when that distance was smaller. So in this problem, next question, it says, what seems to be true in order for the parabola to open downward? So now we're not talking about wide or narrow, we're talking about how these are downward. So let's take a look at what's going on in the pictures again in a different way. Instead of lengths, I'm just going to be concentrating on the focus and the directrix. And in this problem here, you can see the focus is up here above the directrix, and the parabola opens up. In the second one, the focus is above the directrix and it opens up. In the third one, the focus is above the directrix and it opens up. And in the fourth one, down here, already marked it, the focus is below the directrix and it opens down. If you look here, once again, the focus is below the directrix and it opens down. And the last one, the focus is above the directrix and it opens upwards. So when the focus is above the x-axis, well, yes, in each one of these it says x-axis, but in our problem, the x-axis is the directrix. That's not always true. Just for these 6, just for these ones, they put the directrix, every single one of them, on the x-axis. But it's not about it being the x-axis, it's about it being the directrix. So when the focus is above the directrix, the parabola opens upward. And when the focus is below the directrix, the parabola opens downward. So same 6 pictures, but this time we have a different question. This question is saying the vertices of the parabola, it is the lowest point on the curve when it opens upward, or it's the highest point on the curve when it opens downward. So you're looking at this here, one's going downward. This would be the vertex. But up here, this is the vertex. So when the parabola is going up, the vertex is the lowest point. When the parabola is going down, the vertex is the highest point. And it says, where is the vertex located in relationship to the focus and the directrix? So we're looking at this point. Now, we kind of talked about that in the very beginning of talking about these 6 problems, but you'll notice that right here, whoops, didn't mean to do that, just one sec. Right here, I've marked the vertex, and we can see that the vertex is halfway between the focus and the directrix. Well, that happens to be true in every single one of these. Here, the vertex is halfway between the focus and the directrix, and it's true in all 6 of them. And so that is the statement, that the vertex is halfway between the focus and the directrix. You need to write that down. That is the main thing to take away from this part of the lesson. And question number 4, same 6 problems, we're only looking at the bottom left picture. And it says in the final image, the directrix is on the x-axis. And the focus is the point up here. What is the distance between this point right here and the directrix? Well, we can count that out. We can see that it's 5. And we know then if this is 5, then the distance to the focus is also 5 units. Because as we learned early on, that these distances must be equal. The distance from a point on the parabola to the directrix and the point on the parabola to the focus. All right, next little bit. This is, are we ready for more? Have we kind of processed it? We're going to do something a little bit different here. We've got this parabola. And this parabola has, the one that's graphed, has this focus right here, F, and this directrix. But they're saying, what would happen if we moved that focus, we brought it down closer to the directrix, meaning as this distance from the directrix to the focus gets shorter, what happens to the parabola? Well, currently, that distance is 5. And across is 10. So remember, we've now I interpreted this and said whatever this distance is, this distance across the parabola will be twice as much. Or you could say from F, from the focus, to the parabola is the same distance from the focus to the directrix there. So we're going to sketch this new one when it gets down there. Well, the distance to F double prime, because it's move this down to F double prime, or actually F prime, only F prime. That means the distance from the directrix to F prime is 2 units, which means straight across from that, we've got a width of 4. So we know that the parabola we're going to draw is going to have this point at the end of the red, down to the yellow where it's going to have, halfway, not all the way down to the blue, from here to halfway, and back up again. And I wonder if I did do that wrong. This is not the correct picture. We need to redo this picture. What we're going to get here is a parabola. Let me get my pen here, and we're going to have it come down here, and it's going to go. Whoa! I didn't do that quite what I want it to be, but that's close enough. It's hard for me on my pen. I'm using my finger on my iPad. But you're going to get a parabola that's going to have this width of 4 when we have this length of 2. Okay. The next question was, how does decreasing the distance, we went from a distance that was 4, and we had this really wide parabola, to a distance of 2, and now we have a narrower parabola. And what's going to happen there? Well, the shorter the distance between the focus and the directrix, the narrower the parabola. And the last question on this is saying, suppose the focus were at F double prime, which means the focus is right on the directrix. Well, if it was right there on that directrix, the problem is there's no distance between the focus and directrix. So there's no parabola because it wouldn't have any width either. So there's no parabola if there's no distance. That's the end of these lesson notes. And I look forward to seeing you in our Zoom classroom, and have a wonderful day.